In this maiden episode of Museum Diaries, we visit the island of Siargao off the northeastern coast of Mindanao in the Philippines. We will witness how the UPLB Museum of Natural History works with different institutions to produce forward-looking and cutting-edge research. And we will learn how taxonomy and systematics become important in the study of emerging diseases which may be transmitted by bats. We are here at the Siargao Island Wildlife Conservation Foundation. Welcoming us is Dr. Cheryl Yap, an entomologist from the University of the Philippines, Los Baños, and a member of the foundation's board.
Welcome to Siargao Island's Wildlife Conservation Foundation Incorporated.
Del Carmen plays a big role in the biodiversity of Siargao. Almost half of the mangrove cover, around 4,200 hectares, is within the town's jurisdiction. In 1996, Siargao was declared by the government as a protected landscape and seascape, the largest protected area in the Philippines.
Siargao has a unique flora and fauna. That's why it is considered as a key biodiversity area or one of the key biodiversity area in the Philippines.
Siargao Island is a fast-rising tourist destination famous for its coastal attractions and marine resources.
Siargao is now into tourism. Because of the high demand or the influx of tourists in the island, the flora and fauna could be affected.
Despite increasing pressure of economic development, the island and its people make sure to preserve its biodiversity and its environment. Understanding how to conserve biodiversity must be armed with the knowledge of emerging issues that link wildlife and humans. In the case of bats, they are negatively perceived as the bringer of next-generation human diseases. Although this may be closer to the truth, bats, to be fair, also benefit our lives. Bats play a crucial role as they provide important ecosystem services that can benefit humans. Professor Philip Alviola, a bat expert and MNH curator for small mammals and other wildlife, explains these.
For example, for fruit bats, because they eat fruits, they visit flowers, so they can actually help or assist in the process of pollination among several species of fruit trees.
Another important role is through seed dispersal since they are able to fly over long distances.
And in the process, when during that long commute, they can defecate the seeds very long distances from the parent tree, and thereby they can assist in seed dispersal, forest regeneration for that matter. So it's very important.
Their ability as natural biological control can help in ensuring food supply such as rice and corn.
Per night, insects can consume half their body weight.
Insect bats also help by way of reducing insect-borne diseases that can be public health issues such as malaria.
Malaria is carried by mosquitoes, and in the process, bats consume these lots of mosquitoes.
One of the things that the museum has been able to do is to work with various entities to protect human health while conserving bats as well. By working with doctors, veterinarians, biologists, environmentalists, and the communities, the museum does its part to improve and uphold the health and well-being of both man and bats. Bat zoonotic disease research is not entirely new in the country, but at the University of the Philippines, Los Baños, it started out as a collaboration with Japanese universities. Dr. Joseph Basangkay, Professor Emeritus at the UPLB College of Veterinary Medicine and Museum Curator, tells the story.
It began in 2006 when I met Dr. Ishikawa in Korea when I was a visiting professor. He proposed that the University of Tokyo and UP Los Baños College of Veterinary will have a collaborative research on zoonotic diseases transmitted from bats. The main partner institution is UPLB, College of Veterinary, and Museum of Natural History, and the University of Tokyo, and the different universities also in Japan. Okay, since we are interested in the whole parts of the Philippines, so we started first in Los Baños, Then we covered some parts also in Luzon, UP Diliman. Then we went to Pulilio Island, then to Pangasinan, Bicol, and then in the Visayas, we sampled bats from Panay. And then we went down to Mindanao. First we did the Davao area, and then we crossed Samal Island and Talikod Island. And now we're doing it also in Mindanao in Siargao. We found out herpes viridae, and then also suspected dengue antibodies. And then we will try to connect a possibility of Ebola reston, and then also Hendra and possibly Nipah virus.
Shortly after arrival at our camp, our Japanese counterparts are starting to prepare our makeshift laboratory. They have brought all their scientific supplies all the way from Japan. While the researchers prepare the lab, our team goes out to set up mist nets under a coconut area. To hoist the nets up, the team fashioned out wooden poles from the vegetation. The first collection site is under a nearby coconut plantation. The team sets out to install mist nets parallel to the coconut trees. I am with Professor Philip Alviola and two of our museum technicians, Edison Cosico and Ariel Larona. Helping us is veterinary medicine student Alan John Manalad. Mist nets should be properly unfolded. Improper handling, most often than not, would result to lost time just to untangle the nets. There are lots of ways to capture bats, and one way, which the team is doing right now, is by setting up traps using mist nets. Philip explains how the trap works.
So here's a mist net. It looks like a mist because it's almost invisible to the eye, especially under forest condition and during nighttime. So, well, this net works as more of like a deception type. So essentially, the bats or bird for that matter will just go through this net, and then they'll be captured. They'll be entangled by this very flimsy, very thin but strong material of nylon.
To increase the chances of trapping more bats, the team installs more nets side by side.
Yeah, so right now we're trying to set up three nets in a series, so they are side by side, one after the other. So yeah. So Edison right there and with Alan are trying to tie the pole with the net and try to fix it so it will not be it will be stable. So,
We are setting up the nets early, so by the time we are finished, it would be around 6 p.m. That is the time when bats go out to eat or do different biological functions.
So these nets will be set up, will be left open all throughout the night, because bats are of course active all throughout the night, even at the start of the evening, well into midnight, and then even at early morning around dawn. So there's a lot of activity, actually bat activity going on there. So and we'll try to capture bats on those all through that 12-hour night period.
After setting up the series, we went to another suitable site and installed more nets before going back to the camp for a bit of rest. It is already dark. With the Japanese group, we are now returning to the nets to see if there are bats already caught. A few bats have been caught in the second trap, and the Japanese scientists are trying to recover one from the net. With bare hands, Professor Philip Alviola starts to quickly take the bats off the nets. He puts a bat inside a cloth bag, which he hangs temporarily on a string. Edison is taking bats off the net that have been installed at the other site. After an hour of watching the nets, we all return back to the makeshift specimen processing area. The team take their seats to start processing the captured bats. Philip records the calls using a bat recording software in his laptop. He retrieves the bats from the bags and identifies the species. Philip determines the bat's measurements, sex, maturity, and reproductive stage, while Edison records the field data and weighs the bat. After putting the bat in a plastic restraint, Philip hands the bat to Dr. Yumi Une of Okayama University of Science. Dr. Une studies zoonotic diseases from bat ectoparasites. Philip helps her pick off the bat flies and mites from the bat's body. Dr. Cheryl Yap, an entomologist, will later identify the bat ectoparasites using microscopes. Dr. Une then immobilizes the bat using anesthesia before handing it off to Ariel, who fixes the specimen tags on the bat's wing. The bat is given to Dr. Shigeru Kyowa of the University of Tokyo, who, with the help of his assistant Yuki Sugiura, drains the blood from the bat's heart. Dr. Kyowa studies virus infections in mice and bats and serves as the leader of this group of Japanese scientists. After drawing and putting the blood into vials, Kyowa provides a bit of the blood to Dr. Joseph Masangkay and his assistant Alan, who are preparing blood smears. Dr. Masangkay studies the pathology of bat diseases and serves as the coordinator of the Philippine side. Alan John Manalad is a veterinary medicine student who plans to study bat diseases and bat hair microstructure. The bat is then given to Dr. Kentaro Kato and Dr. Hironori Bando of Tohoku University. They dissect the bat and extract various fluids, tissues, and organs. Dr. Kato studies microparasites in bats, such as Cryptosporidium, which can cause diarrheal diseases. On the other hand, Dr. Bando does research on diseases caused by Plasmodium and Toxoplasma, which can be transmitted by bats. After this round of processing, the bat is handled by Dr. Shunpei Watanabe of Okayama University of Science and Dr. Tsutomu Omatsu of Tokyo University of Agriculture and Technology. Dr. Watanabe studies viruses in bats, such as the Nipah virus, Reston Ebola viruses, coronaviruses, hantaviruses, and others. Meanwhile, Dr. Umatsu studies the diversity of the microbiome of bats, particularly diarrheal bacteria such as Campylobacter, which can be potentially transmitted from bats. The bat specimen is then finally sealed in plastic packs with formalin, while the tissues are preserved using liquid nitrogen. The bat carcasses will be stored at the Museum of Natural History for record keeping and for retrieval for other future studies. Work goes deep into the night and continues until the last bat has been processed. Only after that do we call it a day. It is nearly dawn, and it looks like the team has captured a lot of bats in the nets. Though the sun has not risen yet, the team is now going back to the nets. In the furthest net area, more than 20 bats were trapped. Philip buckles down to work on a species of megabat.
Yeah, what we have here is a musky fruit bat, Tinopyrus gabora. It's actually an endemic species. Very noisy, endemic species. The genus Tinopyrus is actually only found in the Philippines as well. So it's a fruit bat, definitely. It's one of your medium-sized fruit bat. It's usually found in a wide variety of habitats, so ranging from forest, second growth forest, and even up to here in this kind of habitat.
Musky fruit bats are notorious biters and can almost rotate their heads. Philip carefully secures the bat's head with a cloth bag as he works on the net. He has to be fast so that all of the bats can be secured before the morning gets too warm. Studying bats is never easy. Aside from staying up late and rising early the next day, you need to be patient.
Oh yeah, definitely. Well, these bats get entangled in so many different ways. They can be, the nets will, they get entangled in several parts of their body, from the wings, from the head, from the foot. So you have to need, special kind of patience for this. And the net itself is very, very thin, very flimsy. So you need a lot of time and patience in order to disentangle just one bat.
A bat handler has to be delicate. Bats can really get stressed and may quickly die. When handling, one should be careful not to apply too much pressure on the bat. At the other set of nets, the team is finishing its collection so the members can move and help Philip. The sun is already high and it's getting hot. The team spring into action. We have used a lot of cloth bags, but there are still more bats to untangle from the nets. We decide to just set those free. This was a chance for Alan to learn, and the people from the museum make sure that he is able to practice taking bats off the nets. It was a fruitful morning because we got more bats than the previous night. We went back to the camp, hungry for breakfast and raring to process more specimens. Working with the Japanese counterparts, especially in processing specimens, is very exact and efficient, as they are very conscious of time and effort.
I always compare it to an assembly line, just like the Toyota car, because when we cut the bat, we process them, then the body weight will be taken, and then morphometric measurement will be done based on a table to determine the exact species of the animal. Then anesthesia will be given, after which it will be completely bled from the heart, and from the blood, many laboratory examinations can be done, including blood smear for blood parasites. It will be centrifuged to get the serum so that it will be stored, and later on it will be examined for the different kinds of viruses. And then the internal organs will be also examined for endoparasites. And as a requirement by the government, since we have a permit from DNR, we are required to archive the carcass. We have to record them strictly so that it can be returned back. Meaning to say, if interesting result will be found out, then we can go back to the particular bat and do further examination.
It is already in the afternoon. After a short break, we are now going to a cave in Barangay Mahayahay to catch more bats. For the past 2 nights, we were able to trap around 50 bats, mostly fruit-eating. This time, we target to get 50 more, hopefully insectivore bats. That is why the cave would be an important collection site, as we expect a lot of insect-eating bats staying there. From the highway, we hike to a coconut plantation and further down to a creek. Its water is fed by a cave. We arrive at the mouth of the cave to install the nets. The team is putting the nets across the water of the creek facing the entrance of the cave. This way, when the bats go out to forage by dusk, they will get trapped. Professor Alviola decides to explore the cave, inspect the bats inside, and try catching and flushing them out of the cave and into the nets. The cave is filled with water just below the knees. The cave's highest ceiling is around 20 feet. There are various formations along the circuitous and meandering passages. After walking inside for 15 minutes, we hit pay dirt and we encounter a roost of bats. Philip tries to catch flying bats with a small net with few successes. He hopes that the bats will fly out of the cave and be caught by the nets. Unfortunately, the bats did not. looks like the bats, although disturbed, did not go out of their lair. So rather than spending more time on site, we decided to go back and prepare the supplies for the processing later and wait for the sun to go down. Before 6 p.m., we were already there at the cave entrance, waiting for the bats to fly out. While we sit around and wait for the dark, Philip recounts what we have done earlier.
We just set up a net in front of a cave, and we're trying to catch a different set of bats. So essentially bats are generally divided into two. So those that are fruit-eating, fruit bats, and you have the echolocating bats. Most of them are insect-eating bats. So right now, I think the bats that are found here in this cave are insect-eating bats, and which means that they are also capable of echolocating. We went to this cave a few hours ago and tried to capture a few species, and all of them are insect-eating, echolocating bats. So these are leaf-nosed bats, and we also caught a horseshoe bat. So yeah, so it's gonna be exciting. And we did see some large leaf-nosed bats as well, but we didn't catch them. So so we're gonna stay here for an hour and try to, capture as many bats as we can, and get more species that we didn't get from our mist net. So it's very exciting. I hope because we'll catch lots of bats tonight.
Just a little bit after sunset, the bats which left the cave early were caught in the nets on the side of the creek. Edison is quick to move to take the bats off the net. Our Japanese colleagues are helping to secure the bats. Soon after, a deluge of bats fly out of the cave and hit the net. And our team quickly take the bats off the nets as fast as they can. In just under 20 minutes, we were able to capture around 60 bats. Yes, we can go back to our camp early for processing. It is already morning. Last night was particularly long, as the team had to process all the specimens collected. Although we have a bit of time to relax before we retrieve the remaining captures under the coconuts, we are again buckling down to work. We hope to finish everything before our meeting with the town mayor. Our documentary here in Siargao is a tale of cooperation between scientists of different fields and two nationalities. Because human health and emerging global diseases are not something to be taken lightly, having this merry mix of researchers is a significant step towards designing better One Health programs where various sectors talk and work together for better public health outcomes.
Actually, this is a very good collaborative research between specific disciplines. VetMed alone cannot do it because as veterinarians, we are very much interested with diseases. However, the technique of catching the bats, identifying the specific taxonomical classification, we have to depend on zoologists, and that is the role of the staff of the Museum of Natural History. And since in the College of VetMed, UP, LB, we have limited resources, especially for high-tech, very expensive molecular techniques. So that will be the role of the Japanese members, especially from different universities, because they can specifically and detail examination. So it's a good collaboration.
At the town hall, outgoing town chief Alfredo M. Coro II and incoming mayor engineer Baby M. Coro talk on their all-out support to projects that revolve on biodiversity and One Health. Research on bats and zoonotic diseases still present challenges, especially in the field. Scientists need to have the support of several sectors, of course, led by the community and private sector initiatives.
So as a conservation organization, SIWCFI works with different institutions, especially the academic community. Our approaches, strategies, and tools for conservation should be science-based. Hence, we are grateful also to this partnership on research on bat zoonotic diseases. We hope to establish even more stronger collaborations with the UPLB Museum of Natural History, UPLB College of Veterinary Medicine, and for Dr. Kyowa of University of Tokyo for many research collaborations across Japan.
Our bat project here in Siargao would not be possible without the aid of the Siargao Island Wildlife Conservation Foundation, SIWCF. They assisted us in every possible way in our stay here in Siargao Island, from our permits, from our food, our lodging, our coordination with several local officials here in the island. So their help was very, very invaluable, and we would like to continue or to do more projects with them. So thank you very much, SIWCF.
Our story on bat and zoonotic diseases research in the Philippines, particularly in Siargao Island, is just the beginning. We all look forward to studying more of the island's biodiversity and ecosystems.